I have to look.
So I'm publishing this in YouTube. So our class will be in the YouTube. So if some of you guys are late, they can just check the link and check the link here. So they can still catch up with us if they join late. And today we will learn about object-oriented programming in Python. And also just wait, guys. So I will post this here. Meanwhile, if you have any questions, also you can let me know.
Hocam benim soru değil de şey vardı. Ben modül 5'i hocam yanlış yüklemişim pre etiketlerini koymadan. Sonra siz bana feedback vermişsiniz. Sonra ben late submission yaptım ama daha bakmamışsınız.
Tamam.
Mail de atmayı unutmuştum.
Tamam. Zaten yani yeni submission olunca bana mail gelmiyor. Ben de işte arada zaman buldukça eski ödevlerin şeyine bakıyorum. Ungraded var mı diye. O şekilde baktıkça yenileri değerlendiriyorum. Ama bakılır yani bakacağım. Ama oldu ki bakmadığım bir şey olursa bana şey yapın. Finallerden önce.
Ama hocam ben de söyleyeyim. Bugün Otlu Class'ta bakarken 9. modülün şeyini yüklemediğini fark ettim. In class'ını yükledim direkt. Haberiniz olsun diye.
Okay, no problem. So here actually I have created this one. So these are the activities we have done so far, the graded activities. So I was planning to have more quiz, but we have 6 quizzes, each of them 1 point, I guess, if I don't remember wrong. In total, it's 6 points, and then we have in-class activity each week, right? So here we have 11 points. And lab, I did it actually initially 3 points. Now I increase it to 5 points. So each lab will be 5 points. So from labs, you can get in total 55 points. Okay, and 11 is from in-class, 6 from the quizzes, and then in total this sums to 72 points. And that means your final will be 28 points. What do you guys think? Sounds good? And I think it makes sense because I feel like you guys spent most of your time for lab, so it makes sense that you get most of your scores from lab assignments. I think lab, it's better that lab has higher weight. But if you have any opinions about this or, I don't know, objections, you can share. But finally, in this case, it will be 28 points and it will be similar to the labs, okay? And my plan is to, in the next week, next Friday, we won't have class like the regular classes. What I will do is I will share the final assignment, try to explain it, get your questions, and as you guys start working on the lab assignment. And during the class time, you can ask any questions you face, problems you face, or questions you have. So we will spend the class time in this way, but then you will have several days more to finish the final exam. And I also think about doing this here in the computer lab. So if some of you guys want to come to, start working on it, at least, face to face, at least to start it, if you have any problems, questions, you want to discuss it face to face, so you can come to the lab, computer lab here. So we will do it in the computer lab, but it's again optional. You don't have to come, but I think it would be nice also to see some of you guys, and we can use 2 labs at the same time, and that's it. So maybe this might be an opportunity for us to also see each other face to face. So sounds good. And I think I just shared this. Why you guys don't tell me? So this is so this is now you can see it, right? My screen.
Yes, William, you can see.
Okay. I was talking about this. So we have 6 quiz, 11 in class. How many? I think 11 labs. So this sums to 72, and final is 28 points. So any questions or comments?
I like it actually.
You have questions? Yes, whenever.
No, I like it. I like the
Okay,
Um,
done.
Teacher, can I ask something? Do we have still chance to change some labs?
You mean your score is not high, or you think you want to improve it?
Yes. Actually,
Okay.
I couldn't see my grades. I mean, in auto class, I didn't see any of them, but
Actually, I didn't grade. I think at least this I didn't grade. I'm not sure about 7, but so I will actually grade them until next Friday.
okay, thank you.
You're welcome. So, and then the other thing I want to say before it's too late, before I forget it, is in Auto class, I think I forgot to create this one, module for lab assignments. I forgot to create this in Auto class, and I think it's not graded, right? I didn't grade your module for labs. I thought I did.
Yes, teacher, I see it now. You didn't put it before.
Yeah, I didn't grade it. So can you guys here paste your the code for from the module 4, please? This decision structure, or just the URL. You can also share this time on the URL, okay? For the module 4 lab assignment, share your URL here as an assignment submission. And if you can do it now, you can do it now, or maybe after class. But try to do it because I will grade them here in auto class. And today is going to be the last class, so we will cover object-oriented programming only in one part, so I will do this part 1. And next week we will do the exam together, we will start together, so next week will be the final exam. And for this lab, I will also try to create a simple lab assignment. It's not going to be, I think, very difficult. Just so that you can practice a little bit more the object-oriented programming in Python, and that's it. So then I'm thinking if I missed something, but also don't forget to put all your, lab and in-class assignments in auto class. I had created before. For in-class, you can just submit the URL. For lab assignments, you should copy and paste all the your code to auto class. So, and then we will start. and today is super cold, so don't go out. And so let's get started. So I don't know if you guys are familiar with object-oriented programming. I guess not so much, right? Maybe you heard about it, but then you didn't practice it a lot. So today we will cover this, and I use this tutorial available here on this website to create today's class, which is, I think, quite useful and makes a good introduction. So let's get started. So I don't have time to make this slide a little bit kind of animation. Sorry guys, because normally what I do is I just show the first sentence and then second I go through them, but didn't have time, so you don't like that you see all the text in one slide, right? It's too crowded. But anyways, in the last class we will survive, and then the next semester I hope I will organize myself better. So basically, object-oriented programming is abbreviated. We use this abbreviation OOP. Is a kind of programming paradigm in which you organize, your software around some objects. You create some objects. You determine what objects you may want to create for your program, and you decide on the relationship between these objects. So everything is kind of built around objects. So it's kind of a approach actually to model concrete real world things like cars, like there are some relation between like companies, employees, students, teachers, courses, right? So if you want to build a, for example, learning management system, there will be many objects, right? Even learning materials will be an object besides the persons. And so the first step in object-oriented programming is to, determine all the objects a programmer wants to manipulate, and then identify how they relate with each other. And this is called data modeling. So if you follow this paradigm, first thing you need to do is to model your software around the data that you may want to store about each objects. And objects, of course, stores this piece of data using something called attributes we will cover very soon. So for example, an object could represent a person with properties like name, age, address, and also behaviors, right? Walking, talking, breathing, and running. For example, you can define a person object. It can have a walk method in which you may provide a parameter like 10 steps, and that this may make the person walk 10 steps. Or even an email could be considered as an object. For example, it has these properties like recipient list, right? Subject, body, and some other behaviors. For example, adding an attachment and sending. So everything can be actually kind of represented as objects that interact with each other in object-oriented programming. So there's these building blocks of object-oriented programming, and I think almost in every language they are the same. And so far, I actually use object-oriented programming a lot in C# and even also in web programming using C#. And over there, you will see like these objects you create with your in your program will also be mapped to the database. For example, if you have an object of, let's say, students, actually then you would have a table called students in your database that keep record of these data about the students objects. So it's very important actually that you do this data modeling perfect at the beginning. Because the more revisions you do is in data model, then that means you will do more changes in your code later in your program. So it's better to determine all these, building blocks at the beginning with very high accuracy. So classes are used, classes are used to create a blueprint for objects. They kind of determine like what kind of attributes and methods the object will have. So they just kind of define the object itself, but they don't store any data. Okay, and we define them as ourselves. We create these classes, and objects are the instances of these classes. And these objects actually the pieces that holds data. Okay, And objects, as we mentioned, can correspond to real-world objects or abstract entities. So classes are used to provide a schema for objects, like their properties, attributes, methods, and then we create these objects from these classes, and these are called instances of the class. And these objects actually store data. And methods are the functions defined inside a class that describe the behavior of an object. So methods actually are defined within the class. It's part of the blueprint for these objects, kind of definition of these objects. And attributes are also defined in the class templates. And it represents the state of an object, and objects will have all their data stored in these attributes. For example, a person who has height, weight, these will be the attributes, and these are the pieces that will hold the data, right? And as if you define all these attributes, methods within classes, and every object you create from this class, every instance of this class will have all these methods and attributes. Okay, so you don't need to define it every time. So you define the ones in classes, and every object created from these classes will have these methods and attributes. So a class is the blueprint for how something should be defined. Okay, so it kind of provides a schema for your objects, how they will look like, let's say, and it doesn't actually contain any data. So it's kind of a template, okay? You can think of like a template. So imagine that we have the dog class, and this specifies that a dog should have a name and age, okay? Depending on the template, your template may include more data if you want, if you wish, depending on the functionality of your program, depending on what you want to achieve. But it won't contain, this class won't contain any data about the name or age of any specific dog. So an instance is the object that is built from the class, and it contains the real data. So an instance of the dog, which is an object, is actually not anymore a blueprint. It's not a template. It's just an object created from this template. So for example, you can create an actual dog with certain name and with certain age using this blueprint, the class. So, and then we will now have a small exercise about this. So we will see how we can apply these ideas, this theory in the practice. So, okay, let me see. I will go back to Replit, and I think I need to publish it. And I think you guys liked Replit, right? Anyone who is not very happy with Replit, you are welcome to share your ideas, because in the next semester we won't use it. The reason is most probably we will learn objective programming language, and I think here there is no objective. It doesn't support objective, so I will try. Oops. And some of you guys have already started. Let me see. No, it doesn't have. So next year we won't be using Replit, which is, I think, a little bit sad. So I won't create a new project. We already have this one here, and I see two of you have already started. So go ahead and so I will also in my computer started. So docs example, we have it here. So I will click start project. And we have already, do you guys have this already or no? Or I already have it?
We have.
We have, teacher.
So I forgot to delete it then. So can you go ahead and delete it? We will write it ourselves, no worries. So I will delete it, and then we will go step by step. Or you can keep it, but you can check what I'm writing here and follow my instructions. So it's your choice, okay? You can choose either way. So to define a class in Python, not surprisingly, we use the class keyword, and then next we write the name of the class, and then here we put the column. So it's almost the same as we define, and in terms of syntax, it's almost the same as defining a function. Okay, this part. So this is the header of the class. And then here we write some code to define this template.
Can you make your font bigger yet? Thank you.
Better. Good.
Yes,
Or even
better.
So, so this is the way we define create a class. So this will be the blueprint for creating the objects. But here I will do something like I will write pass. So using pass keyword is kind of let us define a placeholder that indicates that there will be some code here. But for now, Python compiler, please let me run this code, right, without an error. Okay, so this is the purpose of pass keyword. Normally you wouldn't use it. It just lets you, it just serves as a placeholder here, telling that compiler that there will be some code eventually going here. So at least please, for now, don't cause me trouble. Don't give me an error. So this is the way we create the class, and we always follow the capital camel case naming convention when we give names to the classes. So it always starts with the capital case. So if you have another word, so you just continue with the next word, but with the capital case again. Just for an example, I will delete it. Let's say dog family. Okay, you want to create a class named dog family. So this is the recommended naming convention for the name when naming the class. Okay, so first capital is first letter is capital case, and then the second word for any following words, they are also initial should be capitalized. So right now I will just say dog, and if you go ahead here, just under here, I will print this dog object. Which will create kind of, so this creates with, so we write the, okay, sorry guys, to initialize a dog object from this blueprint class, what we do is we write the name of the class dog, and then you put at the end some parentheses. So this will create an instance from this class, which will be our object. And we want to print this. So this object has no content, has no attributes, has no methods, but it will still occupy some space in the memory. So here we kind of initiate this object from this class. Okay, this is the correct, I think, terminology. So here with parentheses, you put at the end of the class name, you initiate a new object. Later we will see we may pass some parameters here. So I will run this. And as you see, gives me this weird text, right? So this is actually the memory address that indicates where this dog object is stored in our computer's memory. So it just indicates where this object is stored in the memory. It's the address. Okay, and in your case, I think you will get different location in your computers. And we will later see how we can, if the class has more properties to print properly, like the all information about the object, for example, about the dog, it might have a name, right? We will see how we can print it better instead of printing the its location, memory location. So now what we are going to do is, so I will maybe delete this print statement, and here instead of print, so I will define some properties, okay? Attributes, actually they are called attributes, but they are the properties of the object. So to do that, what we do is we need to define with this weird syntax, function syntax, init. Did you guys see it automatically shows up in my case? I will press this, or I think I could just press also tab. That's the one actually. And then here you need to pass self. This is a must. This self refers to the object itself that being created. And then we want to define two attributes. So one is name and another one is age. So a dog will have at least a name and age. So this init is used actually to initialize a object, dog object with some initial values, for example, name and age. So here the name will be name that is passed through this initialized initialization method, and then its object's age will be age. This is also passed from the parameter here. So sorry guys, I will open a little bit the window. So to define property for your objects, you need to use this init function, special function. Okay, it has here two underscores at the beginning, and at the end it also has two underscores. And this kind of function has different category of names, and I will share this later. And here by default always goes this self keyword, which refers to the object being created itself. And here you can provide the values for each attribute. You can pass them here, but at the end here you define the properties for this object, which are called attributes here and here. And each time you create a new instance of a class, this code will be executed. Okay, and here you can provide any number of parameters. It doesn't matter, you can add more things here, but self will be always included as the first element here. Okay, this is a rule. And when a new instance is created from this class, this instance automatically passed to the self parameter. Okay, and then with these values, you set actually its attribute values. Just a second, guys. Okay. And what else here? I think that's good. And here you should pay attention to the indentation. Okay, so we have some indentation to define this function right here. One tab space. In my case, I think I press only one tab. It adds two spaces in Rapid in my settings, based on my settings. And here inside dev, to write your code statements here, you need to add another indentation. Okay, one more tab you need to press. So basically here we create an attribute called name and set its value with this name parameter, and the same for age here. And as you create more instances from dog, you will provide different names and ages. That means all dogs objects will have actual name and age attributes, but their values will be different. Okay. And next, what we have is the class attribute. So I will write here the new one, class attribute. Oops. And it's gonna be species. And in this dog class, we focus on the species called this one. This one. So class attributes are different than these other attributes which are specific to objects. These class attributes defined just under the class header here. Okay, it just goes here, just directly under this class dog definition, the first line of the class name, and they must be always provided with some initial value here. And when a new object instance created from this class, this species attribute is automatically also created with this default value, until you change it for a specific object. Okay. So use, you place, or let me say, you want to create class attribute if you want that all doc instances should have the same value. But if you want them to have different values, specific values, then you define them here. But if for some reason you want a variable that is shared, is value shared by all, instances of the same class, then you may want to define it here. That's the point. So right now, we have relatively more complete class definition, and if you go here and then again print this new doc instance, if you run it, you will get an error, because whenever you create an instance from the doc class and doc instance, it initializes it with this method, and this method says you need to provide 2 more parameters, arguments right here. And here is the error. It says this. It says init function misses 2 required arguments, which are name and age. So in this case, right now, after this point, when you define your initialization this way, then you have to provide some values for name and age for each doc instance you create. So what we are going to do is I will go here. Let's say instead of this, we will create 2 doc instances. So first doc will be, let's say, you can give different names. It doesn't matter. It will be a body. Will have 9 ages. So this creates a new instance, new doc object, and we will assign it to a variable, let's say, called body. So this goes outside of class definition. You see indentation, there is no indentation. It's the same level as the class doc. So this goes outside of the class definition. And then we have the miles. We'll define another doc named miles, and will be the age of 4. So right now, once we define, this, we know that these objects, doc objects, has name and age attributes. So we can actually access them. So what I will do is print, let's say, the body name, right? Doc has, or is years old, right? You can say doc is. And then here we need to provide the age and then years old. So let's run this. So now it's fine, right? As you see, it printed the name and then the year here, and it provided us the correct phrase. The body dog has 9 years old. Or you could just say, I think the body or body. So, and if we repeat the same thing for the next dog, let's say miles. Now it will print the data about the miles. The data about miles is the name and then the age. And as you see, it prints them correct. So here, as you see, we don't have to, define some kind of lists, arrays, or tuples, anything else. So classes, help us, store multiple data through these objects. And how about these spaces? So let's print it. Print body spaces. For that, I will put a space. So which is fine. So how about we change the value of body spaces? As it's gonna change the spaces for miles, so I want to try and test it. So I will say it shouldn't, but body, or we can change this value for miles, right? my species will be, I don't know, family, let's say 2, I just made it up. Now, right now, I will again print spaces for body, and I will print spaces for miles. So let's see, miles has affected the other one. It shouldn't, but so as long as you don't change it explicitly, the value of spaces won't change. And changing initially, all objects will have the same spaces value. Later, you can actually update its value for specific objects if you want. Okay, but it won't affect the values of the other objects. Okay, so once only the object is created, this value is carried, but later it can be changed. In the same way, the same changing the values also works for the other attributes, not only for class attributes. So for example, here body, let's say it's aged a little bit more, and we want to say body age will be 1+. Okay, so now the body should say it has 10 years. So now as you see, it's updated to 10. It just serves as a kind of variable stored in the within the objects, right? Any questions so far? No, everything is good. Let's go this here.
Hocam, why we print 2 times body spaces? First in 19 and second in 20. 2 times.
Why we printed 2 times?
Yes.
Because just for a little test, because here I say these, right, this species attribute is shared by all, its value is shared by all objects. Then I say, okay, let's see if we change this value for one object here, right? Is it gonna affect the value of for the other object? So here we change the minus. So we want to check again body if it still has the same class attribute value. That's why. So
Okay.
and then since that it didn't change, as you see, it's the same as previous one. This value only changed for the miles dog. So that's why. So let's continue. So now we will create methods for this instance. Okay, not only we don't only create attributes, store data, but we also define some methods, which are the functions that can be called from any instance of a class. So you can think of like a function. Okay, they just belong to specific classes or objects. And to do that, what you need to do is basically here you kind of define a function, right? Just inside the class. So make sure that you have this indentation. And here you write description. And as we do with the init here, you have to pass always self. Object here, keywords here. And so description means we want to return, right, some text like this maybe. Okay, so that means this dog is blah blah years old. So what I'm gonna do is return, and we have this special syntax that I have done yesterday. If you write f and then put two double quotation mark here, then here you normally provide some text, right? But what you can do is here you can add these curly braces, insert some variable names, some variables from your code. So here, for example, we want to first print the name, right? So we say self name, and we also want to print self age. So what we want to say is just is years old, and around there you can just add your own string. Okay, so this is a kind of string expression, but using this f keyword here at the beginning, inside there you can add some values from your code, some values of the, could be belong to object or any variable. Is this possible without f? No. As you see, it turns into a whole string, complete string. But when I put f at the beginning, now as you see, we can add this specific of data into this string without any problems. And we will define another instance method, which will say speak. And here, as we do always, self will be the first parameter, and second will be the sound. And so we want to say here animals make some noise. We will say return f again. So we will put first its name, says something, and this sound comes as from the user as an argument here, parameter here. So any questions so far? So we define two functions which are called instance method because this function belongs to this class dog. So let's quit this. Any questions about these definitions?
Hocam, can you repeat why we used F letter?
Here, to be able to insert some data, some values of variables inside a string, we can use this F keyword here. For example, if I delete it, now as you see, everything is turning to a string. Its all color is red. Did you see? So this is not gonna work. It's gonna print this just as it said. It won't know this is actually a variable name. But to prevent this, we put, not to prevent this, but this syntax works with F letter at the beginning of this quotation mark. Okay, that's all we do. We just put F at the beginning of the quotation, first quotation mark. And in this way, using these curly braces, we can put some variable data from variables.
Okay, teacher, thank you.
You're welcome.
Hocam speak'te self.sound yazmamıza gerek yok mu? Daha doğrusu öyle mi yazmamız gerekiyor? Yoksa düz sadece sound yazdığımızda çalışacak mı?
Sanırım sadece sound'un çalışması lazım. I think the sound is fine. I will double check.
Hani şey yapmadık ya, self.sound eşittir sound yapmadığımız için.
This is because when we call this method, I will show you. This is because the sound will be provided by the user. Okay.
Okay hocam.
So I will show you example right now. So let's go and I will keep these definitions here as they are, but I think here I will maybe I will put them here, I will delete them. So we can call, for example, right, parent print miles description. And that's it. So description actually doesn't have any, we don't have to provide any arguments. It just has this default argument which reference the object itself. So we run this. Now as you see, it prints this, it prints the data about the dog using this description function, in which we return the name of the dog and also the age here using this text structure. Okay, but when we wanna call this speak one, as you see, it has additional parameter. That means we need to provide an argument when we make a call to this this function, this instance method. So we say miles speak, right? Let's say roof, and in every language actually they make dogs or animals speak different things. And that's it. So let's call this. So if I don't provide this, I think it was Bora, you will see that there will be an error. It says speak missing one required argument, which is sound. If sound were an attribute here, defined here, right, sound, something like this, then in this case, Bora, we would want to use here self.sound, but it's not our attribute, okay, that's why. And here it's a function that requires a parameter, so we need to pass here, just write roof. Now run this. As you see, now it works. Okay, the value we provide here is passed through the sound parameter and it's printed here. Okay. But here, so if we go ahead and print this miles object, you will see it will still return us this, its memory address, right? Its address is location in our computer memory, but there is a way. It is not a handy way to print some data about descriptive thing about an object. So we have a solution to this problem by using this Ctr function. So here again, I will go to the class definition, okay? And then here we have this special method, Ctr. Again, it has two underscores at the beginning and at the end. And here we pass self again. And then after this, we will have a break. And then here we will return, let's say int f, what we are going to pass is self name, which is more or less the same text as we got here, is self age, years old. Yes, actually the same text. So if we run this now, and as you see right now, thanks to these special methods, where we determine what kind of string we want to return, right? Here we describe the object itself using the name and the age, and here we just print this object as it is here. Now instead of returning its location in the memory, it actually returns me this string defined in this method. So any questions? Now we will have a break until 45 and then we will start. Meanwhile, you can actually revise this code, try to see if it makes sense. If you have any questions, then you can let me know. And meanwhile, I also have a question.
Hocam benim bir sorum var aslında.
Yes, of course, Buse.
Şimdi ben bu en sonuncu şey yazdıktan sonra body ve mile'da hata verdi. Yani altı kırmızı oldu. Body ve miles işte dog body 9 yazdığımız evet o kısmı.
There should be some indentation problem here.
Şey,
Can you check this is like has the same indentation with these ones? And this has additional indentation here. There should be a problem here.
aynı sırada da görünüyorlar ama anlamadım hocam.
Tamam, ben senin koduna bakayım. Hı.
Tamam.
Buse değil mi? Tamam.
Evet hocam.
So I was going to ask, I don't know, sometimes I'm thinking like to record some videos to explain these concepts, right? And then kind of more professional videos, and then share them with you guys, like just as an assignment for you guys to watch them, and then complete in class assignment, and work on the lab assignment, and then maybe in the lab session, let's say we do class in the lab session, and over there, I don't know, you share your code, ask questions, we interact there more. But I also think I also like having these lectures like this way, explain things. I don't know, just want to share mine. But maybe one day I will try this option as well, to give you, prepare these videos beforehand, so that you can just watch them and then do the exercises, try to understand things, and then in the lab, we can interact more over some more examples. What do you guys think? Do you guys like this, or right now what we are doing is better, maybe? Or doing what we are doing and meeting also in the lab, maybe?
I think it's now better, but it can be optional to meet in lab too, if they have questions.
It can be optional to meet in the lab, maybe.
Yes.
Buse, here it has to be capital case, the dog. So this has to be this, okay?
Tamam hocam şimdi anladım. Thank
Mouse
you.
over, like just a question, Buse, just to try to understand how you guys try to solve your problems. Okay, it's not specific to you. Like, do you mouse over this to see what is the error before you ask?
No.
No, okay. Then I should cover these details at the beginning of the class, I think, at the beginning of the semester. Because if you mouse over, did you see what it says? Undefined name dog. And that's how I figured out. That means the dog is not defined because it has to be capital case. So actually I have to make a session like about how we can, find some errors. Like the reason for errors and how you can resolve them. And I think it's important.
Thank you teacher.
You're welcome. So no input about these possible video recordings, and then I don't know. So Oğuzhan, I don't know if you are seeing my screen, so I'm checking the resource you shared. So here we can do kind of like 2D, 3D animations using some physics rules, right? I think maybe Oğuzhan is not in front of the computer because we are in the break, but I just want to ask. So, sorry. Oğuzhan, I couldn't understand if you said something. Okay, you sent text message. So did you try some of these? I don't know how it works, that's why I'm asking. So we plan to use processing here in our next semester instead of Java. Oğuzhan suggested and I checked and I think it might be very beneficial because you can build some, very fast real world things. As you see, this is an example. Isn't this cool? So it follows your, and as I read, they say you can create this kind of things quite fast, build this interface very fast, and while applying your programming language. So I like it also. But I'm also supposed to learn this. Actually, I don't know how to do it. But I think it looks interesting.
Teacher, is there an official site for processing?
Yes, there is an official website. It's normally used for creating digital art, but it can be used for many things. So this is the official website and processing.org, and it has libraries for even Android, for Python, for JavaScript. So it's actually something big. So what is this for? And here there are so many examples. But in this website, I think also, I don't know if you have checked, they just have some animations. Some animations of visual things, as you see here. But the website you sent is nice. And I think I will get this book and then see what I have done.
They are actually interactive. They are not GIFs or videos, but they are actually the code running real time there. And some of those accept input as well.
Awesome. So you worked some of these examples before?
I followed the nature of code. I almost completed it.
Okay, awesome.
Under fractals, there are
Fractals. So this is, I don't know what is fractal actually. I need to check. Okay, I see. So I need to discover. So then, but this doesn't do anything, right? For example, there are things here that I don't get it. And I say reset.
that is the first programmed example of the fractal, so it's very basic.
But
And this is the second one. It's stationary.
it goes more complicated each step.
Yes.
So here you add many circles, right? Just by this code, I think. And then you get this pattern. And here is another
have
example.
current set until because they are not still.
Your microphone is a little bit. Okay, I have to check. No, I just try to find examples that can be interesting for us, you know, for our context, for our department. Because just, you know, making some patterns, I don't know if it's gonna be super interesting, but I don't know, maybe something more interactive will be better. So here it has more things. And as I see, they can be directly embedded into HTML pages, right? Which is nice. Anyway, so we will see, but there are good things here, good things that we can definitely benefit. So I will get back. Yeah, super cool. Awesome, thanks for sharing. Did you guys see? And need to write this code for this. Like it would be great if we, like, let's say, do something that maybe, I don't know, for kids that they can use to learn some science concepts or some applications, you know, that can be used by, I don't know, in educational purposes. That will be, I think, a bit more relevant, you know, for you guys, because, you know, we are in Böte, but yes, those are super interesting. So let's go. So great example. So San says the nature of code shows how to simulate planetary attraction. So which is actually super relevant. So no, I see, yes, I see its potential. Just I need to, you know, find some examples or create some examples that we can, you know, do together and then maybe produce something quite cool that can be even used for some education purposes. So anyway, let's continue. And I think processing will be good for us to cover next semester. Just I need to connect my charger. So let's continue, guys. So next we will actually create a new class, car class, and it will have these two instance attributes, color and mileage, and we will create two instances of car. That means we will initiate two car objects, as you see here. First car will be blue, it will have 20,000 miles, and red car will have some other properties. And at the end, when we wanna print these objects, we should get this text. So can you guys start in your computer using this Replit project? So I will go there and enable it. So back to dashboard. So it's already published actually, so you can go for creating car objects. I hope I don't have the code already there. Or do I? So let me see.
No, it's not.
Okay, good then. So I will click create car objects. So first thing we are going to do is, of course, create a car class and then define this initialization methods, right? And here we pass for self. And the requirement was the car has a color and the mileage, so we need to provide them here. And then we'll provide. We will initialize these attributes. Color will be equal to color, and self mileage will be equal to mileage. And I think that's it. So it didn't ask us to create any properties, but maybe we can create these through the self property, right? So printing object should print its actual properties in a structured way. So we will define this Ctr function where we pass on self, and then here we want to print how was the message. So return to provide f, and here I will provide first the self its colors, right? And we will also provide self mileage. And what we want to say is the colored car has miles. And that's it. So now the requirement was that we create two objects from this car, from this class. First will be a blue car. And then we create this, initialize this object using this car class. And here we need to provide the, as you see, it's already highlighted. We need to provide a color and mileage. And so let's say color will be first one blue. And then second one, the mileage will be 2000, 20,000. So those. Close this. Have to be someone from family. That's not important. So, and then we'll create red car, which will have the color of red. The mileage will be here. I mean, just I want to show that you can actually indicate the name of the property here, and then you can put the value here, right? So it works the same way. So I can also provide the color as here if I want, or no, it's totally optional. But it's important that you write this data in the correct order. If it asks for first the color, then you provide first color, and then the mileage. So you shouldn't, change the order. Order is important. And now we want to print the objects. To do that, I will say okay for. I will use the for loop, and I will put these two objects inside this for loop, and then we'll put them inside this tuple, right? This is a tuple because here we use a parenthesis. Okay, this is different. So since tuples are faster for accessing the elements inside a list, then that's why we use tuples. Otherwise, we could use also actually lists, but here we only care about the speed, and we don't want to change the content of these elements. So that's why we can use just tuple. Then we will print the car. That's it. So we run this. And as you see, it wrote. So any questions about this part? No, is it good? No questions then, so I will continue. So this is just a little exercise for us to create a new object. And so now we will learn about another topic, so specific topic in inherit and object-oriented programming. We have other things as well, like polymorphism and encapsulation. But in this class, we will only focus on the inheritance. So inheritance means actually one class can inherit from the other class. So, for example, and when this inheritance happens, the derived class that inherits actually takes all the attributes and methods of the other class. And these newly formed classes are called the child classes. And the classes that child classes are derived from are called the parent classes. Okay, so for example, you can have a class, base class or parent class here that's called parent class, shape, for example, right? And then you can, when you want to create another specific shapes, for example, circle, rectangle, so you can create these classes that make them derived from this shape class. And these derived classes are called child classes, which inherits all the attributes and methods from the parent class, which is the shape. So it's kind of, you want to create something more specialized version of an object. Then what you do is you kind of inherit the common properties from the parent. And in this child class, you define other the attributes that are specific to this child class. For example, if you inherit from shape class, a class called as a circle. So for example, it has radius, right? This is actually specific to the only circle shapes, right? And so on. So this is the purpose. So, so as I said, child classes overrides or extends the attributes and methods from parent classes. Child classes inherit all the parent's attributes and methods, but they can also specify attributes and methods that are unique to themselves. If I just give an example from the circle classes as child, and the parent classes are like the shape classes. So let's do an exercise. So what I want you guys to do is go to your Teams page and open back the dogs example. So we'll continue with the dogs example. Actually, I don't know why in my case it says start first. Okay, now it says continue. So please continue with the dogs example, the previous one. So we have this class definition, okay? The dog class. This is gonna be kind of our parent class. And actually I like to use the word like base class, okay? And what we are going to do is, so I will delete this existing code. I will only leave the class definition here. And what I'm going to do is I will derive some specifics, dog specifics. Okay, I will define some specific dog specifics, and I want specific classes for each specific. So I will just write so you basically first define the class. So Jack Russell Terrier. And this inherits from the dog class. So you do this by providing the dog keyword here, kind of as an, you're kind of pressing the argument here. And for now, I won't provide any definition, so I will just use the press keyword so that the Python compiler will tolerate this, because missing the class definition. And we can define another specific type that Schund, I think it's German, sounds like German. And this also inherits from the dog class. The last one is the class bulldog. And this also inherits from dog class. And here we also use pass so that it won't throw any exceptions. It says later I will define the provide the class definition. Right now, please tolerate. So that's why we use this pass. So basically, you inherit from a base class, parent class, just passing it as kind of the argument inside the driving class. So this class inherits from dog. In other words, this class derives from this dog class. So this base class, this is a derived inherited class, and this class will have access to all these things here. Okay, it carries over all these attributes and the instance methods. So that means, so if I go here, so I can just, let's say I will define it in miles. This time I will use Jack Russell Terrier, and here you can define as you would define as a regular dog, right? You actually use the same methods because the initialization method here is accessible by all classes that inherits from the dog class. Okay. So as you see, we create just a new instance from this specific class using the same initialization method. So you can add more things. Let's say body will be this time Dutch Schund. I like this how it sounds. Its name will be body, and then its age will be, let's say 11. So that's it. So we kind of right now using the inheritance classes. And so, and if you, for example, just an example, if you want to print miles, I don't know, here. Now, as you see, it prints in miles because our base class, which is here, has this self method, defined, right? So, printing the object will call this method here, defined on this str. Or alternatively, if you want, you can also call the it's the instance methods of the instance. So, for example, body, it has this method item called, let's say, description, which will print the same thing. Okay. So as you see, it also worked. So we have access to these methods that actually belong to dog. We have access to this inside these derived classes, right? Because when you derive, when you inherit, it inherits also the methods. So that's the point that I want to share here. I will check. So here, another interesting thing you can do is actually just not so interesting, but you can actually get the type of an object. So I will get the type of, let's say, miles. So I will run this. As you see, it says it's a type of this class called Jack Russell Terrier, right? So which is good. What you can do here is we also have this specific method is instance, right? It's a special built-in method in Python. So this compares if these objects belong to the same class or not, right? So if I write body and miles, so it will check these objects are the instances of the same class, right? So I will run this. So I expect I will print it. I have to print it. I expect a false. So I got an error. What it says? In which line it gives me this? In this line. What will work? No. I think I tried yesterday and it worked, but okay, let me see body miles. What if I put here, I don't know, dog? No, I think that's the problem. Yes, okay, I understand now. So here is instance. First, you write for this method. You first provide the object. In this case, let's say body, and next you provide the type to check if this is a type of this class. So here we can provide, for example, Jack Russell Terrier, right? And print this is gonna check if this is instance of this class. So run says false, right? Because body is an instance of dash should. So we'll paste this. Now, as you see, it's true. Okay, because body is a type of dash should, it's an instance of dash should. And what if we provide here dog? So what do you guys think it's gonna print? Most probably you guys know the answer. It's gonna print true because body is also a dog, right? So there's this kind of is a relationship. Okay, anything derived from these base classes is actually belongs to that class as well. So every dog created with these classes is actually a dog. So that's why this is gonna return true. Okay.
Hocam, actually,
Yes.
I get error on line 29.
What is the error?
Says typer Jack Russell Terrier takes no arguments.
Then do you have this here?
Yeah, it's same as you.
Okay, I will check again, but there should be something. But you also have this.
Yeah,
We did before.
or could be the same.
Anyone else has any problems? So I will check it out. No worries. Just we have a little bit more to finish, the slides, and then I will check these kind of errors.
All right, hocam.
So I will drink the water. Just a minute. So now what we are going to do is analyze. We will learn about this, defining different methods or overriding this existing methods in these derived classes. And I think we will do this for this one. So what we are going to do is, so every dog may bark differently, right? So we want to provide more options for this one. And so what we are going to do is, so we have this speak method, right? So we can override this method so that it's going to work different for this specific class. So to write it, what you need to do is you define the same function with the same name, okay, just as you do here, speak, and which is the same as here, as you see. And what we are going to do is actually here, we pass self, and we will provide some default value, okay, for this dog. So if no value, sound value is provided, it's gonna choose this as the sound. And we will return again using this F keyword. This is self name. This time we will say says, and then we will just provide sound. So right now, so I will go and let's say go here. We have this miles, right? Created this instance of this class where we override the speak method, and it should function differently because it says instead of actually the original also says, right? So that's fine, but it has its default value. Okay. So in this case, so we have miles, right? So I will go here, and then I will, and for now I will just comment out the rest, and here I will say, okay, print miles, say speed, right? So, and I won't provide any values. Okay. So normally, if it was only a dog object, here it will ask for providing this sound value, but we change it in the Jack Russell Terrier. We say if there is no sound value provided, then just use this as default value. So I will run this. Now, as you see, it says miles says R, right? As you see here. But you couldn't do it with the dog. So if I change this to the dog, if I run this, now as you see, I receive an error because in the base class it requires us to provide some value for the sound parameter. As you see, it says missing one required argument sound. But we override this behavior with this Jack Russell Terrier class, in which case we say, okay, if the user doesn't provide any values for the sound, then just use this default value. And if you want other sounds, you can also provide it. So miles speak, let's say girl. So we run this. Now first says R, in which case we didn't provide any values for sound, and the second one it says her because we provide as well. And so I'm checking what is the next. So, and another thing is, if you do any changes in your base class, these changes are automatically propagated into the child classes, the classes that derive from your base class. For example, here we will do little change that I was planning to do is here instead of face, I will say box. Okay. And what I'm going to do is I will create a new dog just for this one. Say Jim. It will be a bulldog type in which we didn't overwrite anything. Okay, it copies and everything from the base class. Its name will be Jim, and we'll have 5 years old. And we will just print Jim speak, woof, and this, and then next we have the miles. It has its own method. So if you run this, as you see, only the bulldog is affected by the change in the base class, in which case we change it to the barks, as you see here. But the instances of the Jack Russell Terrier where we override the speak method, it actually executes this one. It doesn't do what we define in the inherit class, although you change those changes here. But if it's overridden by an inherited class, these changes won't affect those classes. Okay, but classes in which there is no overrides to these methods, it will just follow these changes in the base class. It will be automatically reflected. Okay. And And this is more or less that we want to cover today. I wanted to a little bit change about something, just a minute, guys. So any questions so far? No, everything is good. So we will create an example. Let me see what I put initially. I think it's just creating shapes, right? I think I changed it to creating persons, employee classes. So let me see if I have some code here already. Do you have this code already in your file or not?
No, hocam.
No, okay. So I did it myself, and now I wanna do it together with you guys. So what we are going to do is actually not so complicated. We will create a person class. So normally when you develop a system where there will be users, okay, almost always you have this base person class, right, which probably has the ID number of the person, name, maybe email, surname, whatever, some properties that belongs to almost all persons. But from this kind of your base class, now from this you create more specialized classes. So if it is a learning management system, then you would create like students, right, instructors, guest students, assistants for the class, and so on. And normally all of them has different maybe properties, different or some specific methods associated with them. Maybe for example, for student there might be a method called enroll, right, and etc. So let's create and go ahead and create this base person class. And we will define this initialization methods as we do with this, to initialize the new instances. And here we will provide like full name, maybe, and then ID number, then we say email. And it's just the typical syntax here we use. Start name will be name. I will copy and paste this. Then I will copy this ID number and email here. And here we can provide a maybe function, right, to let's say print details. And then here we will provide. Actually, I remember I was supposed to do something with the previous exercise, but just a second, guys. Interesting, I can't see it. Anyways, we will do it as in here. Because I thought I had done also the previous one. Sorry. I will get more water. So we have stuff here, and then we want to print. Let's see, my name is. Actually, I want to do it wrong. I don't want to print here. And I want to follow this structure we have been doing. My name is gonna be name, right? So name. For my name, I think maybe it's better employee or username, maybe just username. Is this ID is these right self that ID number, and then email address is, then we will include here the email address. So we have our base class. Let's say we want to create another class from this, derive another class. So we will say, let's say, could be, I think, maybe teacher. Okay. So for teacher, we may have new. So teacher will have all these attributes, right? But they may also have additional ones. For example, the salary and maybe the title. Okay, so I would say maybe instructor better here, like university instructor. And here we will again define initialization function. And here we need to pass again all of them, the same way we did before. Here you need to pass like the name, ID number, email, and right now we will add salary, right? Salary and the, let's say, title. So I will put some column here, and here what you need to do is first we need to define this self, right? Self salary. Salary will be equal to salary. So this is the specific attributes for the instructor class. Self title will be equal to title. But what we want to do is we want this to inherit from person. So we don't want to repeat these, attributes that are common to any person that is working in the university, for example, right? So what we are going to do here is first you need to inherit, right, from this person class. And now all you need to do is this person class should has this init method, right? So we kind of refer to this method. We make a call to this method from this subclass. And here we provide again self, right? Because they ask us to provide self, then to provide name, ID number, and email. And this is so we need to provide the same thing here. ID number and email. So what will happen is when you create a new instance, right, from this constructor class, you need to provide all these values, right? Name, ID number, email, salary, and title. This salary and title will be automatically assigned within this derived class, instructor class, because these are specific to the instructors. But the rest, which are common to all persons in the organization, let's say, then you make a call with the base class, you call its initialization methods, and you provide these values there. Okay, you pass these values to this actually the base class using this against type. Okay. And so next, what we are going to do is we will override this print details methods, right? So we will print it differently for the instructors, because they also have the salary information, and then they have the title. So if you copy this, okay, I will paste it here. I will say, for example, I want to first equal to title. Okay. In Turkey, titles are super important. Subtitle. Then here we provide directly the username, for example, assistant professor Erkan, and has the salary of whatever it is, right? And here we'll provide the, let's say, the salary stamp can be accessed through, and then here we just provide it. So we kind of provide a different template for instructors. Okay. And more or less, I think that's it. So right now, what we are going to do is we will go here, and then we will create a new instance, instructor instance. For example, instructor 1 will be instructor, and here, as you see, it lists all these items: name, ID number. So name, let's say, compare, ID number, whatever. Maybe let's say salary will be, let's say, I will put my dream salary, maybe 20,000, and the title, let's say, just instructor. So I really don't care about the titles, guys. So, and then here we will call this method, okay, print details. So I will go ahead and print these details for the, actually it doesn't make sense. If you define a method called print details, actually it means it just should print it there, right? For return, I will change it to get details, okay, just that it makes sense. So I will change this to get details. I will also change this to get details, because I want to get details. I don't want to print them maybe as first. So here I will say instructor 1 get details. So print this. Now, as you see, it's, since we created an instructor object, so it used this text, okay, because we overridden the default method and then use this text correctly. But if we change this to a person, it's for one, it's kind of person with some, I don't know, I would like to connect as well, some ID numbers, and some email. And then now I will actually put a line break here. Now I will print this. Print person 1, get details. So now it should use this syntax, this template to print this user. Now, as you see, it used the previous syntax. But I remember there was something that I wanted to show. And here I think, so for example, here you indicated person, right? There is another specific keyword, reserved keyword, I think, which is called, I think, super. So this means access to the parent class. Okay, this refers in this case. Parent class for instructor is person. That means this refers to the person. So you can use this super with parentheses. You can use this to refer to the parent class. And it doesn't work because when you, so this is the thing I figured out yesterday, when you use this keyword, right, instead of person, then in this case you shouldn't provide self. If I run this, if I'm not mistaken, okay? So we'll run again. Yes, it works this time. So if you use the super keyword, the same thing, it works the same thing, it's used for the same purpose, but here you shouldn't provide self keyword. But if you directly write the name of the class from which your subclass derives from, then in this case here you have to provide self. Now it's gonna work. But if you don't provide self, in this case, I think it shouldn't work. Yeah, it didn't work. So if you finish this, please go ahead and submit it. This is gonna be the for today's in-class submission. It's gonna be this one, and then that's all I want to cover today. And if you have any questions, you are welcome to ask. If not, I will create a similar lab assignment where you can practice these ideas, and we will see each other, and there won't be quiz, and we will see each other next week where we will start working on the final exam. So any questions? And Ali, did you resolve your problem?
Yeah, Hocam, I got the problem. It was because of the one missing underline before and after init.
Okay. There is a question. Thanks, Oğuzhan. So we will start in the class. I will share it in the class, and then we will. Then you will have several days to complete it. So it doesn't mean you have to finish it in the class, but we will start together so that I can get your questions. And for the time, I haven't decided, but at least I think 2 or 3 days at least. Okay. So from my part, I think it's all for today. If you have any further questions, you are welcome to ask.
Hocam,
Teacher,
Yes, Münevver.
can you come to my code? I couldn't see where's the wrong in my code.
No, this code. And then you can go ahead and ask your questions if you want.
I have an error too. I'll say that.
About this code you have written.
Yes, this code.
Okay, then just wait very fast. What happened here? So if you are good, then you can leave, okay? You don't have to stay. So I will answer some questions that you guys have, and then we will end the session. And I think I will start recording the